This is Geometry Unit 10, Lesson 2 on parallelograms. Parallelograms are a special kind of quadrilateral. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. Guess why it's called a parallelogram? So if we have a quadrilateral with both pairs of opposite sides parallel, it is a parallelogram. Now, a parallelogram has many special properties. So the first one, obviously, because of the definition, opposite sides are parallel. These two sides are parallel, and these two sides are parallel. Now, we also know that opposite sides are congruent. That's the second property. So this side is equal to this side, and this side is equal to this side. Opposite angles are congruent. So if I have this angle, the angle that is across from it is also congruent. So this angle is congruent to this angle. So those angles are congruent. And the other pair are also congruent. This is congruent to this. Those two angles are congruent. And also consecutive angles. Remember, consecutive means next to. Consecutive angles are supplementary. This angle and this angle add up to 180 degrees. They are supplementary. Now, I didn't just randomly pick these properties out and say they're true. We're actually going to prove that these properties are true. All right, so the first thing that we know about a parallelogram, if it's called a parallelogram, its definition says that both pairs of opposite sides are parallel. So if we are given parallelogram ABCD, we can automatically say that AB is parallel to CD. This side and this side are parallel. And also AD is parallel to BC. Because a parallelogram, since we know it's a parallelogram, has both pairs of opposite sides parallel. That's the definition. A parallelogram has both pairs of opposite sides parallel. That's the definition. Okay, so we have proved our first property. Okay, our second property, opposite sides are congruent. Okay, now in order to prove opposite sides congruent, we're going to have to draw an auxiliary line. Okay, my auxiliary line I'm going to draw is going to be a diagonal. I'm going to draw in diagonal BD. Now, why can I do that? I can draw a diagonal BD because 2 points determine a line. And a unique line, actually. 2 points determine a unique line. So I can take any 2 points and I can draw a line between them. So I'm going to draw the line that's a diagonal. So here is my diagonal that I'm drawing in. Now, what does that diagonal split the quadrilateral into, or parallelogram into? 2 triangles. Okay, now, if the lines are parallel, and we want to prove that the opposite sides are congruent, we probably want to prove the triangle's congruent. So, let's prove the triangle's congruent to do that. If the lines are parallel, what do we know about the angles? Well, aren't alternate interior angles congruent? Yeah, they are. So if AB and CD are parallel, that means that angle ABD and CDB are congruent. What kind of angles are those? Those are alternate interior angles. So ABD is congruent to CDB in my picture. If lines are parallel, alternate interior angles are congruent. So those angles are congruent. Now, these lines right here are also parallel. So doesn't that give me another pair of alternate interior angles? Yeah, it does. It would be this pair and this pair. So angle, well, I'll put that in the same answer actually, for the same reason. Angle ADB is congruent to angle CBD for the same reason. These lines are parallel, these alternate interior angles are congruent. These lines are parallel, these alternate interior angles are congruent. Okay, so all we're missing is a side. Well, isn't DB congruent to DB by reflexive? or BD is congruent to BD, bireflexive. And why are those triangles now congruent? Well, let's see. We proved two angles and the side between them. The triangles are congruent by angle side angle. So a triangle ABD, ABD is congruent to, remember your correspondence, if I said ABD, I would say CDB. And we proved it by angle side angle. So by angle side angle, we proved these two angles and the side that's between them. All right, now if those triangles are congruent, what does that tell me about CD and AB? They are congruent by CPCTC. So AB is congruent to CD by CPCTC. What else is also congruent? Well, AD would be congruent to BC. Same reason. So we have just proved that both pairs of opposite sides are congruent. All right, so that's going to be true. All right, so we have the opposite sides are parallel. We proved both pairs of opposite sides are congruent. AB is congruent to CD and AD is congruent to BC. Okay, next property. Opposite angles are congruent. Well, what would be a pair of opposite angles? Well, wouldn't that be angle A and angle C, here and here? Are they congruent? Yeah. Aren't they corresponding parts again? So I can say that angle A is congruent to angle C by CPCTC, because that's part of the congruent triangles. Okay, now the other pair of angles would be the whole angle B and the whole angle D, which would be ABC and CDA. Are they congruent? Well, we proved previously in number 4 that these two angles are congruent and these two angles are congruent. Well, this one and this one and this one and this one are congruent. So what if I added those together? Would they be congruent? Sure, if I take number 4 and add them together, this plus this and this plus this, I would get angle ABC is congruent to angle CDA, using addition on number 4. So I have just proved that this angle and this angle are now congruent. They're opposite angles. So numbers 8 and 9, I have proved both pairs of opposite angles are congruent. So that's also true. And I also want to prove that consecutive angles are supplementary. That's my last one. All right, so I need a pair of consecutive angles. All right, so let's look at the consecutive angles. Let's look at angle A. All right, consecutive means next to. So if I pick angle A, all right, and these lines are parallel, so AD and BC are parallel, what does that tell me about angle ABC if these lines are parallel? Well, they would have to be supplementary. Because if these lines are parallel and this is your transversal, aren't these same side interior angles? Yeah, so angle A is supplementary to angle ABC because if lines are parallel, same side interior angles are supplementary. So that means that any consecutive angles, these two lines are parallel, so that means that B and C would be supplementary. These two lines are parallel, so C and D would be supplementary. So this is true for all of the angles. All consecutive angles are true for this reason. For number 10 reason. Okay, so I'm not going to add that in. So have we proved all the properties? Yes, we have. So all other consecutive angles are true for the number 10 reason. So that's true. So we have this one we have proved because of parallelogram, opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, and consecutive angles are supplementary. So those are all the properties of a parallelogram. So if you know those properties, you can use those properties to figure out calculations. And let's see if we can do those. Oh, I also forgot. We have also proved the following theorem. A diagonal divides a parallelogram into two congruent triangles. So we just proved that theorem because we proved the triangles congruent by angle, side angle. Okay, so now let's do some calculations. All right, in parallelogram TOAD, TO is x squared minus 1, OA is x plus y, AD is 9x minus 3y, and DT is 4x minus 8. Okay, so I want to find the perimeter of TOAD. So I'm going to go around and label my picture. I'm going to go around in a circle. Here's T, O, A, and D. There's my TOAD. Go around in a circle. It doesn't matter which way. All right, so TO is x squared minus 1. OA is x plus y. AD is 9x minus 3y. And DT is 4x minus 8. Okay, now if we want to find the perimeter of TOAD, we have to know what the length of all the sides are. Now, we already know that this is a parallelogram. So all of the properties that we just proved will be true. Okay, so what do we know about the sides of a parallelogram? We know that both pairs of opposite sides are parallel and they're also congruent. So both pairs of opposite sides are congruent. So that means that AD will be equal to OT. This one will be congruent to this one. So we also know that TD and OA will be congruent. Now, since we have two variables, we need two equations. So we have AD is 9x minus 3y will equal OT, which is x squared minus 1. And then TD is 4x minus 8, and that equals OA, which is x plus y. All right, so I want to solve this for x and y so that I can find the length of my sides. I need to know that. So probably the easiest way to do that is by substitution. I'm going to solve this for y to make my life easier. So if I solve this for y, I'm going to move this x over here. That's going to give me 3x minus 8 is equal to y. So now that I have 3x minus 8 is equal to y, I can plug it in over here, just using substitution. Okay, so distribute. 9x minus or plus 24 is equal to x squared minus 1. These will combine to be 0, so that gives me 24 equals x squared minus 1. Move the 1. We get x squared equals 25. Take the square root of both sides, and x is going to equal 5. So now we know x is 5, and it says y is equal to 3x minus 8. So that's 15 minus 8, which is 7. So x is 5 and y is 7. So now we can find the length of our sides. If we did this correctly, the opposite sides should be congruent. Okay, so the opposite sides, 4x minus 8 would be 4 times 5 is 20 minus 8 is 12. X plus y would be 5 plus 7, which is 12. So those two sides are 12. TO is x squared minus 1. So this would be 5 squared minus 1, which is 25 minus 1, which would be 24. And if we did this correctly, this should also be 24. Let's see. 9 times 5 is 45. 3 times 7 is 21. 45 minus 21 is also 24. So that means my perimeter is the sum of the four sides. And so 12 plus 24 plus 12 plus 24 is 72. So your perimeter is 72. Okay, so if the height of TOAD measured from AD is 9, so if I put in my height here, measured in from AD is 9, what is the area of TOAD? Well, the area, remember, is base times height. So my base is 24 and my height is 9. So 24 times 9 is 216. Okay, so that is the basic parallelogram properties. We'll do the last of the notes in class on the next class day.